to when we did solving inequalities, right? If we jog our memory, remember that an inequality is greater than, less than, greater than or equal to, and less than or equal to, right? Those are all my inequalities, meaning that the solution is a range. Joseph, will you put your computer away for now, please? And when we solved inequalities, we just treated that inequality like it was an equal sign. Like all the inequality does is it separates our solution from our value. And so we solved these inequalities, and then when it came time, graphing was the part that was different. You had to graph an inequality. And so if you remember, a greater than or a less than were an open dot, right? It did not include that number, so you drew an open dot around the value, meaning it does not include it. It's an open dot. So it's going to be an open line. Because we're graphing lines right now. So our line is going to be open. An open line. Our line is going to have openings in it. Our line is going to have areas that are open. And then if you remember, if it had an equal sign with it, it was a closed dot. So it's going to be a closed line.
Mr. Sheehy wanted me to tell you messed up on the basketball.
Thank you. Open line versus closed line. It's still the same thing. Open line versus closed line. Just like open dot versus closed dot. We're just going to transfer that information from open line to closed line. And then, if you also remember, if it was greater, right? If the variable was greater, we shaded to the right, we shaded up. And the variable was less than, we shaded to the left, we shaded down. So if it was y is greater, we shaded up, above, or greater, right? Or if our variable, right, any variable, yes. And if we shaded, if it was less than, we shaded down, below, less. So a linear inequality has to be graphed because the information is the shading, right? In inequality, the answer is that value because remember there are infinite answers to an inequality. So today, first step, we're going to solve for y. Because if we're going to graph, it's easiest to graph if our problem says y equals mx plus b. Do you agree with that? Like, y equals mx plus b is the needed graphing form. Except instead of an equal sign, we're going to have what today? an inequality sign. Okay? All of the rules are still the same. Find the y-intercept, plot the slope. All of that's going to be the same. The only difference is going to be how we draw our line and we're shading. You need to remember, though, a special rule about inequalities. If you divide by a negative value, the coefficient, right, is negative. If you divide by a negative value or multiply, right, if your coefficient is a negative value, what do you have to do in an inequality? If your coefficient is a negative value, Henry, what do you have to do?
Flip the sign.
Perfect. Flip the sign. Now, you may not. It may already be y equals, and then we just go on with our happy, merry little lives. But your equation, you might need to get y by itself in order to graph it. And if you have to get y by itself in order to graph it, you might have a negative coefficient. You might have to flip the sign. So you just have to keep that in the back of your brain. So if it's already in y equals, which a majority will already be written in y equals mx plus b form. If it's already in y equals, we can move on, go straight to step 2, which is plot the y-intercept and the slope. Just like we did when we graphed all of our other linear equations, you start at the y-intercept, and then from the y-intercept you count the slope, which is rise over run. And what we normally would do is we'd then take our ruler and we'd draw our line all the way through the graph. But you need to be aware. If it's greater than or less than, it's an open line. If it's greater than or equal to or less than or equal to, it's a closed line. It's dotted versus solid. If it's an open line, there needs to be holes in it. Just like an open circle has a big hole in the middle, an open line has holes in the middle of it. A solid line is colored all the way in, right? It's solid. Just like a solid dot is shaded all the way in. And then this is the part that gets people every time. 3, right here. We can kind of see this because it's kind of similar. But 3 is the part where we get confused. So this is important. Starting at the y-intercept. So you find the y-intercept. Whatever it is. You went up 5 and put your dot, and that's where you started to count your slope. Or you went down 3 and put your dot, and that's where you go to that y-intercept. If y is greater than or y is greater than or equal to, on a coordinate graph, where does y get greater? Which direction in a graph does y get greater? Which way, Gerardo?
Up.
Up. Shade above. So you're going to be at the y-intercept. And if it says y is greater, you're going to shade above. If it says y is less than, or y is less than or equal to, which direction does y decrease? You're going to shade below. These are your 3 steps. The graphing part, the actual putting of the points on the graph is the same thing if it was an equation. The difference is, am I going to make it a solid line or a dotted line? And do I shade above or below? Because an inequality, how many answers does an inequality have? Infinite answers, right? It's anything that's in that shaded region. All right, we're going to refer to these 3 rules. So I'm going to keep them open right here so that I can see them. And let's practice. I have given you graphs for your homework, so we're going to draw some graphs in our notes. You'll be okay. They do not have to be perfect.
Hey, guys, watch.
Thank you. Watch, twin.
Huh? Oh, no.
All right, first one, let's start off easy so you don't cry. Y is less than 1/2 x plus 4. Y is less than 1/2 x plus 4. It's already written y equals, correct? I mean, technically it's y inequality. But I can graph this. So I'm going to draw a graph. It does not have to be perfect, but it needs to be decent. Oh my goodness. You just have to be able to accurately count a slope. So where does this graph begin? What's my first step? What's my first step? Where am I going to start this graph? At the y-intercept. What's the y-intercept of this linear inequality? Positive 4. 1, 2, 3, 4, right there. And then from that linear, right, from that point, I'm going to make my line by my slope. What's my slope? 1/2, 1 over 2. So it means up 1, rise, over 2, because they're both positive. And I want more than that. So what else can I do? Brayden, take your earbud out, please. What else can I do? Instead of going up and to the right, how can I fill in more? Kinley? -1, -2, because negative and a negative make a positive. I'm going to do it again. So this part is not new. We've been doing this with linear equations, correct?
Yeah.
The new part is step 2. I plotted the intercept and the slope, but now I need to decide, is it dotted? Is it an open line? Or is it solid? Is it a closed line? Is this going to remain open or closed? Open. So I'm just going to go like this.
Whoa.
I'm not making it a solid line. I'm making it a open line. The answer cannot be on this line. The ordered pair cannot fit on this line. And because it's an inequality, I have to shade a little bit. Starting at the y-intercept, I need to decide, am I shading above or am I shading below? So, my y-intercept, and it says y is less than, which means up or down? Down. So everything below gets shaded in. The answer, the solution, if you pick any ordered pair in that area and you substitute the x value and the y value, like 1, 1 is in this shaded area, well, half of 1 is 0.5 plus 4 is 4.5, which is greater than 1. Any ordered pair in this area provides a viable solution to the inequality. If I asked you, does this point right here work for the inequality? Is it a solution? The answer is no, because the line is open. The answer cannot be contained inside of the line. It can only be contained below. Any ordered pair below this line, when substituting the x value and the y value, makes it a true statement. If you substituted a value on the line or above the line, it would be false. Let's do another one. Let's do y is greater than or equal to negative 4x minus 3. Y is greater than or equal to negative 4x minus 3. So again, I'm going to draw a decent graph. Doesn't have to be perfect, but it needs to be workable. Where does this graph start? Starts at negative 3. So I'm going to go down 3. And then my slope for this is negative 4 over 1, correct? Yeah. Meaning I go down 4 and to the right 1, but I don't have any room for that. What else could I do? I could extend the graph. Or instead of doing down 4 over 1, I could do up 4 backward 1. This part is not new. This is the same thing as a linear equation. The new part is it dotted or solid, open or closed, and which way do I shade? Open or closed? Closed, because it's equal to. I'm going to start at the intercept, and I'm deciding, do I shade above because y is greater, or do I shade below because y is less? Y is greater, so that means that's this way. So it's everything on this side of the line. So, any ordered pair in that shaded region, which is infinite, right? Or any ordered pair on that line, because it's a solid line, it could be equal to. Any ordered pair, if you substitute the x value and the y value of that ordered pair, you will get a workable solution. Last one. 3x minus 2y is greater than or equal to negative 6. So there are two ways to do this problem. Let's get y by itself first. I want y by itself. So what do I need to move away from the y first? Pretend this just said 3 minus 2y. What would you move first? I'd move the 3, right? So I need to move the 3x minus 3x minus 3x. These are literal equations. And I'm left with negative 2y is greater than or equal to what? Negative 3x minus 6. Good. Is y by itself yet?
No.
No. I need to divide by negative 2.
5.
Now y is by itself. My coefficient was negative, so I flip the sign. And here's the additional part. Negative 3 divided by negative 2 gives you a decimal, doesn't it? Mm-hmm. And that's my slope value. I don't want a decimal. I want to keep it a fraction. So I'm going to leave it, but I'm going to change it to positive because two negatives make a positive. Negative 3x divided by negative 2. Well, two negatives make a positive. Leave it as a fraction because this is my slope. And this, negative 6 divided by negative 2 is positive 3 plus 3. Can you graph this now?
Yeah.
Not my best graph, but it'll get the job done. Where does this start? Positive 3. My y-intercept is positive 3. 1, 2, 3. My slope is up 3 over 2. What do you need to do? I can't go up. My graph isn't big enough. I can't go up 3 and positive 2. What can I do? Negative 3, negative 2, negative 3, negative 2. Am I going to make it solid or dotted? Because it has an equal to line, right? Here's how I think of it. If it's got a line underneath it, it makes a line. And is y greater or is y less than? Y is less than, which means down. So I'm going to start at the y-intercept, and I'm going to go down. So it's anything in here. Could the ordered pair be on the line?
Yeah.
Yes, because it's solid. Or anywhere in this shaded region.